ever wondered how to connect multiple destinations using the shortest possible path? That, my friends, is what we call the minimal connector problem. It's a fascinating concept in mathematics that has a lot of practical applications in our day-to-day lives. Imagine you're a network designer, tasked to connect several cities with the shortest length of cable. Or maybe you're a city planner, and you need to figure out the most efficient routes for garbage trucks. In all these scenarios, you're dealing with the minimal connector problem. In simple terms, the minimal connector problem is about finding the shortest path, or paths, that can connect a number of points. It's like a puzzle. The goal is to reach all the points while traveling the least distance. And don't think this is just theory. From planning the quickest delivery routes to designing the fastest internet networks, the solutions to these problems shape the world around us. This is where the concept of a minimal spanning tree comes into play. So, what exactly is a minimal spanning tree? Well, let's dive right in. A minimal spanning tree is a subset of a graph. This graph connects all vertices or points without any loops and with the least possible total edge weight. But what does that mean? Imagine a small network of 5 towns. Each town is connected to every other town by roads of varying lengths. Now, we want to connect all these towns using the shortest possible total road length. That's where the minimal spanning tree comes in. It's like a map, a guide that shows us the shortest possible route to connect all towns. It carefully selects the shortest roads, ensuring that each town is connected without creating any loops. This way, it minimizes the total distance traveled, hence the name minimal spanning tree. It's like a puzzle, finding the shortest route to connect all points, and it's a fascinating part of graph theory. Now that we've understood what a minimal spanning tree is, let's see how it helps in solving minimal connector problems. So, how do we use a minimal spanning tree to solve a minimal connector problem? Well, let's dive right into it. We start by identifying all possible routes. Like a spider spinning its web, we lay out all the paths we can take in our network. Now, don't get overwhelmed. This is just our starting point. Next, we eliminate the longer paths. Think of it as a race, where only the fastest survive. We're not interested in the scenic route here. We're all about efficiency. So, any path that is longer than another that connects the same points, it's out. Finally, we select the path that results in the minimal total distance. This is where our minimal spanning tree comes into play. Using our small network example, we'd choose the paths that cover all points while maintaining the shortest total distance. And voila! That's how we use a minimal spanning tree to solve a minimal connector problem. Let's quickly recap what we've learned today. We started with the minimal connector problem, a fascinating mathematical puzzle that asks us to connect all points in a network using the smallest possible total length. We discovered its relevance in various fields like computer networking, civil engineering, and even in planning airline routes. Next, we delved into minimal spanning trees, a concept that provides us with a systematic way to find that shortest possible path. We learned how to start with one point, and then keep adding the shortest possible edge that connects to a new point, until all points are connected. We then applied this concept to solve minimal connector problems, a process that demonstrates the practicality of this mathematical theory. Understanding these concepts and the process not only enriches our mathematical knowledge, but also equips us with tools that can be applied to real-world scenarios. Remember, a minimal spanning tree is not just a concept in mathematics, but a practical tool for solving real-world problems. Want to rise to your full potential in your studies and revise like a boss? You can trust Study Guide Today to have you covered. Subscribe to this channel and see our website linked in the description of this video to see revision articles to maximize your study gains.